Hello and welcome. You're watching NewsX and I'm Vaishali Kohli. Now the stage is set for the launch of the LVM3-M6 BlueBird Block-2 mission from the second launch pad at the Satish Dhawan Space Centre in SHAR of Sriharikota, scheduled for Wednesday morning at 8:55 a.m. and 30 seconds. The Mission Readiness Review Committee and the Launch Authorisation Board granted clearance for the mission on Monday. Following this approval, the 24-hour countdown commenced at 8:55 a.m. and 30 seconds on Tuesday, marking the final phase of preparations. Indian Space Research Organisation Chairman V. Narayanan, along with senior scientists, is stationed at the SDSC SHAR to oversee the launch of the heaviest satellite ever carried by the LVM-3 launch vehicle, popularly known as Bahubali. LVM-3 has an impressive record of 8 consecutive successful missions. And with that, let's go to the big screen and take a look at what are the components and features of the LVM3-M6 launch vehicle. Let me take you through the details, viewers. Now, LVM-3 launch vehicle, key components, of course. The overall vehicle, 3-stage medium to heavy lift launcher with solid, liquid and cryogenic propulsion. Now, strap-on boosters, solid rocket motors providing initial thrust. Those are the key components. The core stage, liquid fuel stage with 2 Vikas engines, upgraded HTVE variant for enhanced thrust. The upper stage, cryogenic stage for precise orbital insertion. And the payload fairing, of course, protective enclosure for the satellite during ascent. Now, the modular design, let's talk about that now, allows flexibility for various payloads, including human-rated versions for future Gaganyaan missions. The indigenous technology now, let's talk about that. Fully developed in India, featuring the CE-20 cryogenic engine and advanced avionics for autonomous flight control. High reliability, 100% success rate in previous operational flights, incorporates redundant systems for navigation. Enhanced thrust, now HTVE in L110 stage, provides improved performance over earlier Vikas engines. So those, of course, viewers, are the details. And now I do have my guest joining me on the broadcast. I have with me Dr. Surendra Pal, former Director, ISRO. Doctor, of course. Now let me go across to my first guest first. Now, to begin with, Dr. Surendra Pal, I'd like you to explain to our viewers how big a day really it is for India today.
First of all, I wish to greet ISRO and India that we have reached to that stage where one of the important satellite, BlueBird 6, almost 6.1 ton, is getting launched by LMV3, which is now we consider it as the most reliable vehicle in that category. And of course, let me clarify it here. For us, every mission is important, but this mission becomes slightly more important because this directly feeds to the international internet network and 5G, 4G, direct communication with the mobile handset. So that's a great thing, which already BlueBird 1 and 5 are providing for United States, Canada, and some of the other countries. That's one thing. And a successful launch has got 2 factors in it. One is we've proved is a launcher which will be worthy for launching a Gaganyaan. Second thing is we are very reliable as far as international launches are concerned. Okay. And third thing, our design is robust. Yes, there are improvements which are being done. I understand from the LMB team, from many of my colleagues who are in ISRO, that a lot of improvements are being thought. But we do the improvements in a gradual manner until they are qualified at 3 levels. We don't put just like that. Okay. Even if it's reliable. So we are very conservative as far as things are concerned, but at the same time we are quality conscious. So it's a great step as far as ISRO is concerned, and I wish it will be successful. Thank you.
All right, that was, of course, Dr. Surendra Pal, former Director, ISRO. Now, I do have with me Dr. B.R. Guruprasad, former ISRO Scientist, Director of Jawaharlal Planetarium, and Group Captain, Dr. V.N. Jha, former Joint Director of DRDO and former Indian Air Force officer, also on the broadcast. Now, I want to go across to Dr. B.R. Guruprasad. Now, Dr. Guruprasad, my question to you really is that how different is the BlueBird Block 2 mission from Block 1?
Good morning to all of you. Namaskar. See, BlueBird Block 2 satellites are much bigger. The very first thing which is apparent is, BlueBird 1 Block 1 series of satellites, they have, let us say, about 700 feet antenna, 700 square feet antenna, but this Block 2 satellites have their antennas. They call it as phased array antennas. Let's not worry about too much of technical terms. Okay, they can steer the beam electronically, and it is about 2,400 square foot. In fact, you can understand as to you can appreciate as to how big they are. In terms of mass, also they are nearly 6,000 plus. And these satellites are going to provide cellular broadband data to ordinary mobiles, in fact, ordinary mobile smartphones. So if you have your smartphone, the satellite which will be circling the Earth at a height of about 500 kilometers, roughly, that is the orbit which we are putting 450 to 500. From that distance itself, it will be capable of transmitting the signals directly to the mobiles. Here, I would like to tell you one thing. This satellite, Block 2 satellites, specifically, since today it is being launched, the first one in the Block 2 of AST Space Mobiles, it acts as a mobile tower. All of us have seen mobile towers when we travel across the city at different places. So the only difference is, instead of mobile tower being here in a city on the Earth, this satellite, BlueBird Block 2 satellite, first satellite in that, it acts as a mobile tower in space. So this is the thing. Now let me tell you what is the context of this. There was a time when satellites which were communications, whose purpose was providing connectivity, communication satellites, they were launched to 36,000 kilometer high geostationary orbit. But it has got its own challenges. And there will be latency, that is delay will be there. When you say hello, you might have observed during anchoring. In fact, your reporter will be able to say only after a few seconds he or she will hear and respond. So here at a height of only 500 kilometers, that problem, latency, will be less, very much less. And the other thing is, today in low Earth orbit, we call it as within 1,000 kilometers, Elon Musk's SpaceX is providing through their Starlink satellites all the broadband internet data and other things at the global level. And Amazon's Jeff Bezos company, that also has entered into the fray. It has already launched some satellites in their low Earth orbit communication satellite network. And now this is the AST Space Mobile. This is the third one which is entering into the fray. It is already providing some services, but these satellites will significantly enhance their services. And more importantly, that satellite, such a sophisticated satellite, such a heavy satellite, such a satellite which is very vast from the point of view of the dimensions of a satellite, is being launched by our launcher LVM3, which is already emerging as a reliable launcher. That is the USP of this launch. All of us as Indians have to be proud of it. Thank you.
All right, I'd request all my guests to stay on with me. Now that we've taken a look at what the features are, let's take a look at how the mission will be carried out. So now let me take you through that, viewers. So how will this mission be carried out? This, of course, is 2 into S200 ignition that we're talking about. The solid strap-on boosters ignite, providing initial thrust for liftoff. Now, the liquid core stage activates while strap-ins continue burning. So that's the L110 ignition stage. Now, the 2 into S200 separation, the liquid core stage activates while strap-ins continue burning. Now, the payload fairing separation, 5 MOGAV fairing jettisons at 116 kilometers altitude to reduce mass. Now, the core stages shuts down and separates. That's the L110 separation happening. And the C25 ignition. Now, the cryogenic upper stage ignites for precise orbital insertion. So that's the C25 ignition stage now, where at the C25 shutdown, the upper stage completes burn. The BlueBird Block-2 separation happens and the satellite deploys into target orbit. Mission complete. So that's the BlueBird Block-2 separation, and this is where the mission completes. Now, that, viewers, is an overview of what really happens. And now I have with me, I want to go across now to Group Captain Dr. V.N. Jha. Now, Dr. Jha, the idea here is to simplify this for our viewers, because this is, of course, a lot of technical jargon. So, now, other than what my previous guest, Dr. B.R. Guruprasad, has explained about the fact that this acts as a mobile tower in space, would you like to explain to our viewers the other key technologies, of course, which are being tested in this mission, in simple terms for our viewers?
Well, very good morning to all our viewers. And it's a proud day for ISRO and India that our proven satellite, LVM, is going for the 6th launch. The basic aim here is, of course, the satellite has been manufactured and is being controlled by US company, and we are only launching. So the entire work schedule, the mechanics and the scope of the satellite, we don't know much about it. That US will be knowing it. We are only putting into the orbit. Putting in the orbit, just for the sake of simplicity for your viewers, I must explain that the satellite in the lower Earth orbit needs to have a velocity of the order of about 7.6 to 7.8 kilometers per second. That is the type of velocity which is required to be given to the satellite. Then only it will be stable in that orbit. If not, if the velocity is less than that, it will fall down back to the Earth. So that is the type of velocity that it has to achieve. Secondly, when the satellite is injected, as you mentioned, the satellite would be injected at about 520 odd kilometers here in this case. They have chosen to be about 52 degree or around 52 degree of the inclination. That means it is not the polar orbit, it is somewhere in between. Just to reconcile the previous experience, our International Space Station is also in the orbit at around that 51.6 degree is the inclination of the International Space Station, and this particular satellite is also going to be somewhere close to it. So it's the US objective what they are putting this satellite into it. Maybe that they may be having a close contact or close sort of interaction between the controls of the satellite as well as something happening in the International Space Station. I don't know, but it is a possibility because these are going on the same, almost the same path. Third thing is there that when this particular satellite is being launched, the initial part, of course, the strap-on engine is there, so it is a solid engine. Subsequently, the second stage will be a liquid engine, and the last stage, which is part of the part of the injection, is the cryogenic engine that will be going on. So all three systems you are going to see into the play, and that has been the motto of the entire GSLV project. GSLV is having on the three-stage motor, first stage of the solid propellant, second stage of the liquid propellant, and third stage is the cryogenic propellant. And after the launcher, after the rocket goes beyond the atmosphere, that is about 100 kilometers that we talk of, we call it von Karman line, from where the space environment starts. Below 100 kilometers is the stretch of the atmosphere, and beyond 100 kilometers we understand theoretically that there is no atmosphere, though it is not correct. There are some amount of molecules of the air here and there that is encountered. So after it goes to the space beyond 100 kilometers, that payload fairing separation that goes off, and then satellite is free on its own. And when this particular velocity is achieved, about 7.6 or 7.5 kilometers per second, that is the time when it will be injected in that particular inclination. So this is what it is going to be there. And then thereafter, after we have injected the satellite into the orbit, desired orbit at the desired height, then the entire control will be in the hands of the US agencies. Thereafter, they will be doing the minor maneuvering of it to put it into the precise orbit, to rotate or orient the satellite in a way that the entire solar panel is facing the sun, and lot of energy will be directed with that. Antenna will be directed where it is supposed to be. So this is what we are going to see. So ISRO's task is only to inject the satellite into the desired orbit, and then thereafter US will take over. And last, I would say that every launch has got some value addition. Now, for the first time, we are going to see the GSLV, the LVM mark of it. It is going to carry the payload in excess of 6 tons. It has not happened earlier. So I compliment ISRO that they are going to take this to that order. And of course, LVM has got the capability of carrying out about 8 tons of the load in the lower Earth orbit. So we are going to see further augmentation of the capability in the coming days, coming months or years. So that is how it all going to be there. So we are anxiously waiting for the zero countdown. When it happens, satellite will soar to towards the sky. That is how it is going to be there. Last thing, I am also an environmental activist. That every time that the satellite is being launched, particularly the heavier satellites like the SpaceX has got it, like what Russia has got it, China has got it, their satellites, their rockets. It leaves a huge amount of exhaust in the stratosphere, and the stratosphere is one place where these exhausts don't come back to the earth with the convection cycle. There is no convection. The convection is reverse in the stratosphere, that anything gas or molecules which has got the heat absorbing capability, that is greenhouse effect that will be caused, that is going to remain in the stratosphere. So of course our satellite is a very small one, our launcher is a very small one, it won't leave much of the exhaust, but every launch of SpaceX, China's Long March, or Soyuz rockets of Russia, they are going to leave huge amounts of pollutants in the stratosphere. That is a matter of concern, and we hope sometimes some regulatory body takes a note of it. They prevent the spoiling of our atmosphere. Back to you.
And now, of course, viewers, the countdown has begun. 3 minutes, 88 seconds to go, 18 seconds to go. Really, really interesting. There, we're showing you the countdown right there on your screen. But now I want to go across to Dr. Surendra Pal, former director, ISRO. Now, Dr. Pal, if I ask you, what really are the biggest technical challenges when it comes to the preparation of this kind of a launch?
You see, first of all, any launch is a challenge for us. Now, in this particular thing is concerned, the satellite is a large one, it is put in a stored mode, and when flaring comes out, because of the jerk, etc., and vibrations, nothing should be get, and we take care of these things. When it's put into the proper orbit, and the orbit to be, we are in a process, and we have got the competency in that one. We achieved the skill to put the orbit almost in the exact fashion. We don't, not much of a, maneuvers are to be done. As far as LMB3 is concerned, that's the thing. And then we track it. We give the initial parameters. All those our tracking networks, which are almost spread across the globe, or India, ISRO's own network, they will give the exact position to AST, okay, BlueBird. As far as BlueBird is concerned, I think I must add one line here, that the new communication systems which is going to be there in this one, with the multi-beam, beams are steerable, the polarizations are steerable, there is a frequency reuse is there, it can have 4G, 5G thing directly to your mobile, and the power is such that inside the buildings also you can have it. That's what I read it. I don't know, and I think BlueBird 1 to 5, they have demonstrated this thing. So if you see that one, we are installation at 55 with the phased arrays which are steerable. You can have a communication even on the pole side, where the velocity is, where population is very rare. It's population is sparingly put there, so you can be used. So it's a total system when complete of BlueBird. It will cover almost all the things, 5G data, and of course it may also do remote sensing. We don't know which are the secret payloads on that one, which we won't be knowing, which US only will be knowing. But as far as a common man is concerned, it will be a big step. My friend Dr. Guru Prasad has already told that it's possible to get rid of those ugly mobile towers which are there almost everywhere. And besides 5G, 6G, it will also provide you video, very good quality of video. It means your DTH will go away. So it may have it may revolutionize the total thing. As far as LMB3 is concerned, it's when we go to LMB4, maybe we can launch much more bigger satellites into the orbit. And what Dr. Group Captain Jha talked about it, yeah, there are problems in the stratosphere, but when most of the time it's our CS, 25, which is a cryogenic engine, okay, and which does not pollute the stratosphere. So once this Vikas puts into that orbit, after that, most of the maneuvers, separations are done by CS25. So in that stage, there is no pollution. So I think I must make it clear. And futures will be only cryogenic engines, or maybe there's a lot of research is going on the ion and propulsions, which will be used for satellites, may not be for rockets. So future things will be much better. But there is a crowd in the orbit, and orbit is quite crowded in the low Earth orbit, and the satellite persons have to take care of the collisions, like how we maneuver our collisions, our IRS series of satellites, how we maneuver the ISS, all those things will be done here also. So all precautions are taken. Nowadays we have got strong computers, very capable computer. A network is there which can detect in small things, of the
All right.